Welcome to the TPC desktop video series on using Traverse PC for the Public Land Survey System. In this video we're going to take a look at closures and areas. I happen to have a section that we've entered here. It's the same one we used in the section 1 video, and we're going to come in and take a look first at the closure that we ended up with in the last video, and then we're going to do some things on the grid versus geodetically, and take a look at the 2009 Manual of Instruction and how it says to come up with areas. So let's start here in the closure view, and I want you to notice right here that our linear error, 1/100th of a foot, so we've got a real high relative error, good closure on this one, and we end up with 603.25 acres. Now if we come back into the Traverse and highlight one of these areas here, or one of these distances, we see that we're working with the geodetic distance at the elevation of 4,300 feet. So that's our project elevation. And the bearings that we are working with are true bearings using the mean course convergence. Let's come up here to our formatting, click on the Advanced tab, and let's tell Traverse PC that instead of using the geodetic computations for the Public Land Survey System, let's go back to a straight grid distance and grid bearing. Now I'm going to come back into this Traverse and tell Traverse PC I want to recompute it. So this is what we would get if we were in a COGO program that didn't understand how the Public Land Survey System worked, or wasn't capable of doing geodetic computations. If we come down now to the closure view, we see that our closure is now 1.17 feet, okay, and our area has changed to 603.29 acres. So this is that whole thing of apparent misclosure because we're not able to accommodate convergency in this particular Traverse. Now if we take a look at section 223 in the 2009 manual, where it talks about areas, it says it's acceptable basically to come in and enter this data and then do a compass rule adjustment on the data to remove those errors, and that will compute the appropriate area for us. So we're right back to our 603.25 acres. Of course, the problem with this is that we've computed positions for these corners on the grid, and we've balanced them, so we're not really quite sure where we're at. However, we could turn on the details, adjustment details, and find out how much each corner moved. But really, what I like in the 2009 manual is that in that same section it says, other geodetic computational methods found in textbooks can produce similarly reliable results. And although Traverse PC's computation methods aren't directly out of any textbook, the manual opens the door for what Traverse PC does. It takes a different approach to actually computing the areas. So let's go back to the Traverse, set it up for those geodetic computations, and then let's come in and talk about what Traverse PC is actually doing. So we're going to go back to our geodetic distance at mean project elevation and mean course convergence to give us our true bearings, and let's come back and do a recompute on that. And what you'll notice here is that I'm working with the same raw data in both cases, whether I'm working with grid coordinates or geodetic positions. So it's simply a matter of telling Traverse PC how I want to do the computations and then telling it to recompute. I don't have to re-enter any data anywhere in here. So let's come back to our closure view now, and we've got our appropriate closure, okay, of 1/100th of a foot around this section, and we've got our appropriate areas here. What Traverse PC has done in computing these areas is that it's gone back to the selections I used in the Traverse, where I said I want to use true bearing and geodetic distances at project elevations, and it's taking the coordinates that Traverse PC has computed for each one of the geodetic positions that got computed in the Traverse. So we compute the geodetic positions first, we compute the corresponding coordinates on the state plane grid, and now we do a straight double meridian distance area computation, but for each piece, and I talk about them in pieces, but for each computation in a double meridian distance, we use those positions based on the latitudes and longitudes to compute the appropriate scale factor, elevation factor, and convergency. Throw those into that double meridian distance. And what's nice about that is that I basically get the appropriate area then based on the appropriate geodetic positions of all these corners. So even though we're doing this on a single section right here, think about expanding this out to a township, and basically all my closures and all of my areas are geodetic closures and geodetic areas matching what I would get if I had gone back and, in this case, done a compass rule adjustment to come up with my appropriate areas. So I don't have to go back and kind of do those kludges, those kind of makeshift ways of coming up with appropriate areas and closures. I can do it directly from the geodetic. The other thing I want to show you in this video is that I want to go up to the View menu, and we get to tell Traverse PC what data we want to include in this closure view. And I'm going to tell Traverse PC I also want to include the PLSS errors. So Traverse PC adds a new section to the closure view, and here I've asked for information on the relative error of latitude independent and departure independently. So we've added up all the latitudes involved and then taken the latitudinal error and come up with a relative error, and done the same thing for departures. Now we've just put in here that these are per the rectangular limits, and depending on how much interest there is, we can come back and basically apply many of the rectangular limits in the manual to this closure, and Traverse PC can tell us whether our limits are acceptable or not in this particular traverse. Kind of some neat opportunities for us here.